In this video, we are going to cover compound expressions, or I should say, we are covering reading and writing compound expressions. This is VL-1018. Let's go ahead and get started. So, what's an expression? An expression is a mathematical statement made up of numbers and operators. Operators are like the plus, the minus, the times, the division, but also operators like, the square, or to the second power, or like, to the third power, or cubed. So those are operations or operators. So a couple things that we should know, like things you probably should memorize. Whenever you see the word sum, that relates to addition. So the sum of a number and 2 is n plus 2, or 2 plus n, because order doesn't matter when we add. The difference of a number and 2, difference has to do with subtraction, so that's n minus 2. And how do we know? Well, it said of a number and 2. So that means the number goes first and 2 goes afterward. When you see the product of a number and 2, that's multiplication. That can be written as 2 times n, majority n, or n times 2, or it could just technically be n2. But this is kind of the standard way to write it. And of course, order does not matter when we multiply. It's the commutative property of multiplication. Quotient has to do with division. So the quotient of a number and 2, that's n divided by 2. The number goes first because it says number, and the 2 goes second because it said it went second. Division could also be written like this, like a fraction. They both mean n divided by 2. But we also want to know the term squared, which is raised to the second power. So when you see a number squared, that means a number raised to the second power. And whenever you see a number cubed, that means you have this number raised to the third power. So let's go ahead and take a look at some compound expressions and look for some strategies, because these are just hard. There's no real easy way to do it, but there are some strategies that can be really, really helpful. So I'm going to show you one that works well for me. So number 1 says 3 added to twice a number. So 3 added means I'm going to be adding 3 to something, so like plus 3 or 3 plus something. Kind of doesn't matter because we're talking about addition here. We're adding that to twice a number. Now, what does twice a number mean? Twice a number is 2 times a number. And what is our number? It's our variable. It's a number we don't know. So it's 2n, and we're going to add 3 to it, so 2n plus 3. Now, if you wrote 3 plus 2n, because you're thinking, oh, well, you put the 3 first because it was on the left side. That's fine, too. 2n plus 3, or 3 plus 2n, they both mean the same thing. Let's try number 2. 4 taken away from 7 times a number. So 4 taken away from, that is subtraction. And then you've got your second part, 7 times a number. Well, 7 times a number, and 4 taken away from. So 4 taken away from, that's subtraction. And then 7 times a number. 7 times a number is just 7 times a number. But this is wrong because this word from, we call that or I call it a switch word. And a switch word is like the word from, or sometimes the word than. And if you see from and than, you'll find those sometimes in statements regarding subtraction. What that means, why we call it a switch word, is instead of being in the beginning, it now goes to the end. So a switch word means, wait, cross that off. This no longer belongs at the beginning, it goes at the end. So where we're switching the order of the numbers, instead of starting with the 4 and then ending with 7 times the number, we put the 7 times the number at the beginning and the 4 goes at the end. So now this is 7n minus 4. And yes, the order does matter when we're talking about subtraction. Let's try number 3. 2 times the sum of a number and 3. Whenever you see the word sum, I think it's a really good idea. Whenever we see the words sum, difference, product, or quotient, but to use parentheses. Because if we add parentheses to an expression, it's not going to make it wrong. It might not be the most simplified, but it's not going to be wrong. So if I see the word sum, I want to immediately put parentheses around it. So sum. And then when do I end my parentheses? Well, after you see 2 different things. So the sum of a number, okay, number is the first thing, and 3. Oh, that's the second 3. So sum of a number and 3. And kind of like PEMDAS, you're going to work with parentheses first. So let's start off with the sum of a number and 3. The sum of a number and 3 means the number goes first, the 3 goes second, and sum means addition. Put those in parentheses. We're not done because it says 2 times that. Oh, that means we need to multiply it by 2. So 2 times the sum of a number and 3. You technically don't even need to put that multiplication symbol. You can put a dot, you can put the little x, or you can put nothing, and it still means the same thing. So 2 parentheses n plus 3. 5 times the difference of a number and 7. Again, we see one of our key words, difference. Let's use a parentheses. So difference of what? Let's see, the first thing is of a number first, and 7 next. So difference means subtraction, so n minus 7. We have our 2 things, so we're going to close our parentheses, so n minus 7. And we're not done because it says 5 times that, so we are going to multiply this by 5. By the way, if you put times 5 at the end, or just put the 5 at the end, that's still technically the same answer. The same expression. It's an equal expression. It's an equivalent expression. So you can put the 5 at the beginning or at the end. Let's try number 5. It says 5 added to the quotient of a number. Oh, there goes one of our magic words, our key vocab terms, quotient. And we want to look for the 2 things. Quotient of what? Of a number. That means that goes first. And 3. And quotient means division, so n over 3, or n divided by 3. We are not done. Oh, sorry, put it in parentheses. We are not done with this because this is 5 added to that. Oh, that means plus 5. You could also put the plus 5 at the end if you're like, oh, 5 is being added to it, so it goes at the end. Kind of doesn't matter. But one thing you ought to know is that this can also be written as n divided by 3 like this, plus 5. Or the 5 going in the beginning. Kind of doesn't matter. Both are correct. Let's take a look at 6. 7 taken away from the quotient of 4 and a number. We see the word quotient. That's one of our vocab words that we want to put parentheses around. Quotient of what? 4 and a number. So those are 2 things we're getting the quotient of. So 4 goes first in this case. The number goes second. Or you can also do 4 over number. Anyways, that goes in parentheses, 4 divided by n, and it says 7 taken away from. So we might want to say 7 taken away from. Sorry. Oops, wrong note. Wrong colors. You might write 7 taken away from. That's 7 minus. But, as you can see, oops, let me change the color. From is a switch word. Than and from are switch words, which means the 7 goes from the beginning. It switches to the end. So it should be 4 divided by n minus 7. So that should be our expression. You could also write 4 over n minus 7. You may notice there's no parentheses around there. You can have it, but you don't have to when you write it like this, like a fraction. And technically, you kind of don't need it here either, but it's okay. If we had it there, there's nothing wrong with that. It's an equivalent expression. Number 7, 3 times the sum of a number and 8. Ooh, there we go. We see the word sum. Now we need parentheses around it. We need a sum of what? A number and 8. Okay, those are our 2 things. So number and 8, and it's a sum, so plus. Put those in parentheses. So 3 times that. Oh, well, just 3 times means 3 times like that. Or just 3. 4 times the difference of 2 and a number. Oh, difference. That's our vocab word. Difference of what? Difference of 2 and a number. Those are our 2 things. So it's 2 and a number. Notice I'm going in the order that they gave us. 2 goes first, number goes second. 2 goes first, number goes second. Difference means subtract. And they say 4 times that. So that means we're timesing it by 4. Number 9, a cubed number subtracted from 8. A cubed number. Now we could use parentheses here, but I think we don't need to. So we have something, a cubed number. So we have a number, and we have to cube it, which means raise it to the 3rd power, and subtracted it from 8. So that's subtraction, and that's 8. And then we've got to think, wait a minute, from is a switch word, which means, whoop, the 8 doesn't go to the end. The 8 switches to the beginning. So our answer is 8 minus n to the 3rd. Let's take a look at number 10. The sum of a number and 4 squared. So sum of a number, that goes first, 4, that goes second. So we're done with those. Sum of a number and 4. Sum means add. And then they want us to square it, which means the square will go on the outside. We know because there's a little comma which says, hey, you kind of stop here. Sum of a number of 4 kind of go together. So that means we end the parentheses there and then put a exponent on the outside. Number 11, 3/4 of a number. Fraction, whenever you see a fraction in the word of, that means multiply. So this is 3/4 times n. You could also just write 3/4 n like that. That's also correct. Number 12, the quotient of 4 and the okay. So the quotient of 4 and the difference of 7 and a we got like 2 keywords. So imagine if you're doing PEMDAS and you've got parentheses and parentheses inside of parentheses. Deal with the innermost parentheses first. So let's start a new parentheses with difference. Difference of what? Difference of 7 and a number. Okay, cool. So let's deal with that first. The difference of 7 and a number, 7 went first, number goes second, difference means subtract. Put that in parentheses. And now they're saying the quotient of 4 and this difference. So quotient of 4, quotient means division, and the 4 went first, so we're going to start off by writing 4 divided by 7 minus n. We can also write this as a fraction, so 4 divided by 7 minus n, and that would be correct as well. If you want, you can put those 7 minus n in parentheses, but you don't have to. All right, let's try number 13. The sum of a cubed number and 2, so sum of a number and of a cubed number and 2. So the first one is a number that's cubed, and the second number is 2, and it says sum, so we are adding them. Let's take a look at the next one. The cube of the sum of a number and 2. That sounds so similar to the last one. The sum of a cubed number and 2 versus the cube of the sum of a number and 2. So what's the difference? Well, if we use our strategy, this should help us figure it out. So sum, I'm putting that in parentheses, sum of 2 different things. What 2 things? First one is number, second one is 2, and that's where we end our parentheses. So let's do our parentheses. A number and 2, and sum means add. And they say the cube of this thing right here. Oh, that means we cube it, like that. Let's take a look at 15. The product of 7 and the square of a number. So start our parentheses. Product, oops. The product of 7 and the square of a, square of a number. Because if you just said the product of 7, which means 7 times something, and the square of something, it's like the square of what? It's this is not correct. So it's a square of something, so it's a square of a number. So product means multiply. There it is. The product, which means multiply. And if you want, you could put parentheses around it, but you don't actually have to in this case. Let's try 16. The square of the product of 7 and a number. Holy cow. Let's try this. The square of the product of 7 and a number. Those 2 things, so let's put those in parentheses. The product of 7 and a number first. And then they square it. So here's the first one, 7 times n squared versus, in parentheses, 7 times n squared. Those 2 are different things. They are not equivalent. They are not the same. And yes, you can write number 15 like this without a multiplication dot between the 7 and the n. Let's try, you've got 4 more. The quotient of 15 and a squared number, so let's try that one. Quotient of 15 and a number, not just any number, but a squared number. So quotient, we start with 15. Quotient means divide. Squared number is number squared, and end our parentheses. Now it turns out, hey, look at that, we don't need a parentheses for that. You can also write this as 15 over n squared. Both are equivalent. Let's try 18. The square of the quotient of 15 and a number. All right, let's try that. Quotient, what are the 2 quotient of what? 15 and a number. So 15 goes first, quotient number, put that in parentheses, and they say it is the square of it, which means we got to square that. Let's try 19. 9 taken away from, oh, I already see a switch word, so we know that we're going to have to switch things at the end. 9 taken away from a cubed number. So we have our cubed number, a number cube, which is to the third power. And normally 9 would start there, but because we see our switch word, it goes at the end. So it should be 9 minus 9. So n to the third power minus 9. Let's take a look at number 20, the cube of the difference of a number and 9. Goodness gracious, okay. Difference of a number and 9. So number goes, and that's our in parentheses. So difference means subtract. Difference of number goes first, 9 goes second, because that's what it says. Number goes first, 9 goes second. And so we need to put that in parentheses. We're not done because it says the cube of it. So now we have to cube this, which means raise it to the third power. And there it is. These are compound expressions. They are not easy. But the more you practice, the better you'll get at them. And if you find using the parentheses and then looking for like the two things that, it's the product, square, sum, or difference of, if you find that helpful, like use the parentheses strategy. I think it'll really help distinguish between like terms like this, n to the third minus 9, and n minus 9 in parentheses to the third power, because they are very similar. The wording, it's like got all the same words. So anyways, try some problems on your own. Good luck.